Hi guys, I'm very happy to have Andrey Vasnetsov as my guest today. Is an expert and actually renowned and very well known startupper, I would say, startupper and engineer from Berlin who builds and has balls to actually endeavor on vector search. And for everyone who doesn't know what that is, if I simplify it in one sentence, this is what drive the whole machine learning and artificial intelligence behind the scene in terms of search and discoverability. And we're going to be, delving with some details around this topic. But first, back to Andrey. How are you doing, Andrey?
Hello, Sergey. Thank you for the invitation. I'm quite good.
So we actually meeting in Las Palmas de Gran Canaria, where I had a chance to attend a meetup that you've hosted with the whole team. And I love the fact that you've organized this offsite. And I guess one of the Andrei idea came from another Andrei, your co-founder, who has been advocating for spending a lot of time in the sunny Las Palmas. And it was super cool presentation. And by the way, for everyone, we'll try to link the presentation in the description below, so everybody could understand more about vector search and vector databases. And it looked like you didn't have enough time, so we decided to follow up and get more information about this topic. And I will throw it right in. So when I look at your LinkedIn profile, you literally says that, guys, I prefer practical approach over academia. And you being the graduate from Bauman University in Moscow, it's actually known for fostering culture of true and hardcore engineers, the guys who, as you describe, do things with their hands.
That's
And
correct. Yeah.
and looping back to you, could you just tell me the story? How life was when you were a student. What brought you to who you are right now? Like who inspired you during your academia? I would love to learn more, about your student times.
Sure. Well, actually, I started my studies in the university from completely different topics. I started it with robotics, and I wanted to build my own robots. This manufacturing robot hands which can weld together cars and other equipment. So it was fascinating by it at the time. So my first year was on this faculty. I was studying a lot of physics, a lot of math. But after I discovered that there are other possibilities which might be more aligned with my vision of what I want to do in my life. So later on, I switched more into the programming rather than mechanical studies of the moving parts of the robots.
Looping back in your starts in programming, what was your first language? What made you curious about next steps?
Yeah, so I was curious about programming long time before university. I started with Visual Basic. Basically, I had a lot of free time during my summer vacation, and yeah, I basically spent it reading through this book I found on how to build the first very primitive programs. It was basically a single window application which had only one button and it showed one piece of text. It's something which currently anybody can do in web using JavaScript, but at that time you kind of had to do a whole setup around it. You had to install a compiler, install a IDE, and then program everything from very bottom up. Yeah, that's how my journey started. Later, I switched more into the web part of it. This PHP, HTML, and also JavaScript. At that point, I guess I also started looking into Python, but not exactly started working with it. So I guess by the time I started my first course at university, I was mostly a PHP developer.
Well,
But
we all started with PHP. There was
yeah.
at least in my professional academia, there was like the first go-to language to build any practical application. And do you remember what was your first computer?
Oh, my first computer. I don't exactly remember what the model it was, but it had 500 megabytes hard drive, and I was struggling to run Age of Empires on
You,
it.
like I remember I've saved money. I was already on my first grade, and I bought Pentium 166 hertz computer, and with 5 gigabyte of hard drive. And I was thinking, oh my God, what am I supposed to do with all this memory? I thought that like the whole world could fit into this hard drive. And I love how this whole thing evolved because the history of software is strictly coupled with history of databases because they cannot exist with one another. And funny enough, I actually believe that mainly why the whole leap of database evolution started so quick right now, thanks to hardware. Because before, when we look at 60s and 70s, the like it's been done on the magnet tapes, so even the software was not able to operate so quickly. And a lot of time when you ask questions on the street, I've done this survey, if you talk to people and you say, what is database, hardware or software, a lot of people have hard time to basically break it down and understand that it's all about software, because they believe database it's all storage, like a physical storage. And when you're doing this demo, it is so incredible to see how far we are from this belief. Like it's all about based on software.
Right. I guess it's especially true for vector databases, even though the vector databases themselves doesn't require any special hardware, but they kind of rely on advancements in neural networks, and neural networks just couldn't exist in its current state without GPU acceleration, without all this huge data centers and very expensive equipment, very expensive. How would you say, like a new industry is built around computations for neural networks, and its foundation is advancements in how you process tensors and how you process matrices. It's not a linear computation anymore. It's not a CPU. It's something different. It's vectorized on the computational level. That would basically unlocked advancements in neural networks, and those neural networks unlocked and created industry for vector search and for vector databases.
Well, I really love presentation of your colleague at the meetup, and she presented one slider with evolution of search, and and this actually happened pretty much in the last 20 years. Anything before we wouldn't consider pretty much search. It was more of a getting data out with I don't know. Let me throw like a simple questions. When you talk to any engineer and you wrap the term search, we think of select from. Like this is our normal entry to the search world. How different it is what you do with vectors?
Right. What you typically understood by search in databases is exactly this select from statement, right, where you specify the exact criteria which should match for your records, and you get this result sorted by some field, and that was basically a search. And search is evolving into a direction where we specify those criteria for selection in a less and less exact way. So right after these conditions comes the text search, and text search is able to work not of the tables, but on the unstructured text. So you have a lot of text fields, some documents, and you're able to select those which have some specific terms. And moreover, it's not just exact terms, but you also pre-process them. So, for example, words with different endings can still be found, even though they are not exactly in the same form as you search them. And I guess vector search and vector discovery goes into the same direction. It allows you to specify the criteria even in a much more relaxed way. You do not longer rely on exact matching of keywords. You just create something which represents the meaning of what you want to find, and use this to get the results.
Great. And, also from the example of Atita that from the meetup, she showed two searches. One was like, I'm looking for a jacket with pockets, and then I'm looking for a jacket without pockets, but without and with pockets. It's not part of the keywords if in the traditional search, query that we do. Therefore, you would probably get exactly the same results. So with what you're saying, vectorizing of search makes the search a lot smarter, because you could be context driven, or basically think not in the keywords but rather in meanings, or broader formation of our thoughts. And I would love to loop this back to practical application. So the most common way would be generally apply this in any consumer e-commerce. We're looking for a product, we want to be specific, and by the way, I know you prepared some image to describe how difficult it is. Maybe you could just bring it on a screen to highlight how difficult it is actually with simple words to search for something without the context.
Right. Maybe before showing the image, I would describe a bit more where we came to this understanding why we need a next step after just search, because the similarity search and vector search itself existed for quite a long time. It existed inside big corporations which could afford training neural network models on their data. It existed in academia for quite some time. So from this perspective, we didn't invent anything that radically new. But what I wanted to talk on this conference, and what I guess we are going to talk now, is actually the next step after vector search, and that is something what I call vector discovery or exploration, if you will. And the key difference here is that sometimes you don't even know what you are looking for. You cannot explain it with words. You cannot use reverse image search, but you still know the destination where you want to arrive at the end of the process. And I guess that's where I want to share one single picture. Let's take a look into it. Can you see it?
Yeah, I see this, and I think everyone else seeing that.
Right. So this is something I faced myself during some online argument. I wanted to find this picture, but I didn't remember exactly how it looked like. So I didn't have image file, and of course I didn't know how this thing is called. So my options was quite limited. I was going to the Google. I was trying to describe it with just different words, different phrases. But each time I tried to do so, the results was completely irrelevant. And the worst part of it is that you do not know, like, in which direction should you change your query to be closer to the result. Basically, each time you type a new query, you make a random guess, and there's no way to know in advance if you are getting closer or not. So that was my first approach. My second approach was like, okay, I have some results from my previous search. What if I just go and click on different images, which looks closer to what I'm looking for, but not exactly, and use similarity of images to search for this thing. And I did that, and unfortunately, it didn't go exactly well, because whenever you click the next image in the Google or other search image, it's basically a separate request. It doesn't know the context of what you are looking for. It repeats the process from only the latest request which you made. So whenever you click a new image, it will only search for those which are closest to this, but it will end you up in this sort of similarity bubble. So everything you will see will somewhat close to the original image, and you won't be able to like escape this bubble if you just use a single latest image as a search request. So there is no history, there is no context, and basically there are also no instruments to build a search or like exploration process which could include this history in your queries. And that's what we are basically trying to solve with Qdrant. It's our a long-term vision of how search will evolve after just similarity search, after just closest. It's also called KNN, like K nearest neighbor. So our understanding is that K nearest neighbors is just a single application, and there should be something exist beyond just this.
But Andrey, let me like basically understand this better for myself. So what you building is actually ability to play Akinator. I don't know, you know this game, like when
Yeah.
but with your own mind, and you have to be you guessing and you every time you're adding up on your guess, it gets you closer to the results or to the vision where you're heading.
Yeah, it's
Anything until
actually a great example because in Akhenaten you have a set of questions, right? Each question basically splits the space of possible answers into two parts, like a positive and negative one, right? And by utilizing this binary search, essentially, you can find exactly the place, exactly the character you were looking for. But I cannot have limitations. I cannot can only work with structured data. Basically, you need to label each character in your database with a set of properties, set of traits, and only after it's done, it can function. But in real applications, you might not have this set of rules, you might not have this set of traits, and of course you don't have time to label everything with it. And
I would love to.
discoveries, yeah.
I would love to exactly challenge that and describe like idealistic like search that I'm looking for, and you could tell me if this is going to be possible in the few months or years.
Right.
So I'm imagining that I would love to live in a place in the world with a constant temperature or average temperature of 24 degrees, where there is always a smell of bananas. So we're bringing something unstructured. So smell is something, and where I could hear the breeze of ocean. So we have sounds, and it has a very close proximity to, let's say, a barber shop, because I need to constantly trim my beard.
Right.
Would vector search could bring me close to exactly identifying some spots on Earth where I would, consider to call a dream home?
Right. So actually, your query consists of several components, right? So first you specify a temperature range. Second, you specify the location from barbershop. Those parts can be considered structured because we have maps, we have like Google Maps, we have like all the information where each like shop or other venue is located. So we can pretty much do this part without any kind of vectors. We just select a place in a map which satisfies those two conditions. The smell of bananas is more complicated. We don't have a direct information about it from our database. Yeah, I don't think any hotel will have this checkbox on their booking.com page, right? So this we should infer somehow from this third-party sources. Like, for example, there is an image of the view like outside of the hotel, and if there is like palm trees, it can be closer to bananas, other than like other image which have a birch, for example, right? And this part is actually can be described with similarity search, because bananas will be closer to palms rather than birches.
One of your keywords at the application was multimodal search, and this is where you say
Right.
vectors will we call discovery. Like, can you mingle about that? Like, what more could be described or could be used practically with the discovery search?
Right. If we're talking about multimodal, in practice, in current like applications which actually work, it's mostly about combining text and images in the same query or in the same data set. So if you have hotels, if we're talking about hotels, there is like text description of the hotel and also picture of it. And there are encoders or neural networks which are able to convert both text and images in the same vector space. In this case, we can, for example, search images by text or texts by images. What we couldn't do with just a simple regular similarity search is we could not combine both text and images into the same request. So for example, if you are looking for the hotel and you have a picture of the hotel, and you say in the text that you want this kind of model, but you want it in a different architecture style, for example, right? So you describe some picture of like a beach house, but you want not a beach house, you want a Baroque type building, right? If you do this in the same query, there will be conflicts because multimodal representation doesn't really have the capacity to understand which part of your query is more important, which part of your query is less important. That's why if you are searching across images, the image part of your request will always dominate the search, and the text part of the search will always, like in 99% of cases, will be just ignored. That's a consequence of how this embedding space looks like internally, how it's structured during the neural network training process. And
yeah, like I instantly had another question that I wanted to look back with exactly this example. Robots. Like
right.
you started your career, you wanted to build like one armed robot with multiple applications. And I'm just thinking, by the way, I was in a cafe yesterday. You should also go to this place, Los Arenas, and they have these robots, waiters. They bring coffee to the table. I was like, oh my god, like how it's like we don't have it in Berlin. At least I haven't seen it yet. But I imagine that robot collects constantly multiple data sets, structured and unstructured, like sounds, visuals, location based, proximity sensor, etc. And if you would have to constantly use single search query to whatever database to have to identify what should be the output of input, it would be either very slow robot or very expensive robot. So theoretically, I'm thinking, I'm just like, challenge you with this idea that vectors could radicalize speed of robotics by having multimodal search done in almost real time. So then the robot, I'm just imagining the robots that you invented, like one-armed robot, he could collect multimodal data entry, like from all kind of structured, unstructured, sound, videos, images, and based on that take decisions. So decision is basically the algorithm that tells you like, okay, do this or that. Am I right in my thinking? Am I close to believe that this will happen?
So when we are talking about multimodal encoders, multimodal search, we usually assume that both components of this multimodal encoder are unstructured. So if we're talking about image and text, so both text is unstructured, just like free-form text, and image is also unstructured, just random photo or video or something. But in case of robots, those telemetry which you mentioned, that proximity sensors, other types of like lidars maybe, which is built in, is actually more of the structure side of the spectrum. So it is, of course, possible with vector search to combine structure and unstructure in one request, but this part was already mostly solved. It was in production since several years already. The challenging part is, I would say, create structure using unstructured data, or define some kind of direction in the vector space using unstructured data. Because when we are talking about this context for the search, right? When we want not just the latest click to be considered as a query, but the whole search history. What we actually want is to create structure from the unstructured components there.
Yeah, this is incredible because it opens up so many kind of ideas that how what could be done with that. Like it's and if you ideate with your team, what are the craziest or the bravest idea you were thinking, okay, that wasn't possible before, or that was basically very cumbersome before. With vectors and discovery vectors, it is going to be solved or basically applied on a daily basis.
So in our understanding that everything should be changed, like starting from the very beginning, the interface itself, as you usually imagine search, like it's a text input of some form, and you type keywords there. But those interfaces, they were designed like 50 years ago for keyword search, and basically currently it's just a legacy, which is only preserved because everybody is used to it. If we want to really unlock the potential of vector search, of vector discovery, we would need to invent new types of interfaces which won't limit you in just text, which would allow you to provide uh, various forms of feedback to the system, so it would understand better in which direction should it continue the search after the first result is arrived. I guess in this case, very interesting practical examples would be applications like TikTok, where the signal from users is collected in completely different form. Unlike YouTube, you're no longer liking or disliking videos. In TikTok, you just scroll faster or you scroll slower, and this signal is much stronger for recommendation algorithm which TikTok uses, and that's why it is able to much faster get you the content that you would be addicted to.
This makes me feel uneasy. I was more thinking in the direction of basically Neuralink, kind of like the application that we believe in the future will enable us to do a lot more with our brain. And then when you say, okay, that we need to drop legacy search the way it's been designed. So if we are able to provide multimodal search with all kind of unstructured data and structure that in specific vectors, then I'm thinking like if I would have any kind of, well, it's not that I wish, but probably this is where we're heading, any device that is embedded in our mind, and I could because the way we think with images, we think with some kind of like meanings, and each meaning in your head might be different than mine, but it triggers similar emotions. So we could already kind of like look for closest neighbor, and the search of how we think is probably already what happens in our brain. This is already kind of like we think in vectors. We think in basically in meanings. It's just embedded in our biology. And and if I would leap forward in that step, then I would be already above TikTok. So probably TikTok is going to be probably embedded in my brain. I would just like consume some emotions if I wanted to consume.
Right. So that's actually why the language itself is required. So the language is just a form to represent those vectors, which could be understood by different people, right? And if you have a device which is linked directly into your brain, it doesn't need language anymore. You don't need to talk with this device in the same way you talk to ChatGPT, for example. You can directly think in vectors, in embeddings, and if this device is installed in your brain long enough, it should be able to recognize patterns without converting them into the words first. It will directly hear your thoughts, and you will hear its response in this form of thoughts, I guess, as well.
I love that. My first degree, I'm a linguist as well, and I've been studying languages and the structures. And I think that this would work with one condition, that the cultural code is equal to the opponent. Because I imagine the world where you would grow up on Mars and I would grow up on Earth, or like on the other planet. Like, we're going bollocks now and like talking about this stuff, but it's actually interesting. So the vector search probably would work if we build similarity based on the same cultural code. So the meaning of good and evil, red and white, would be the same for you and for me. And if you would grow up on Mars, probably you would have 100 tons of red and no white at all. So probably, I just assume that the meanings of search would be different than my meanings of search. But I'm like,
Yeah.
this is just like a small offset for us to basically mingle about the future.
Yeah, I guess the further away your culture is, the more formal protocols of communication you would prefer, right? If you are trying to talk with somebody from another planet, you probably want very strict rules. What you want, like how you want to present your information, and you don't want to use any kind of local memes of your planet to communicate.
Yeah. Andrey, I would love to step back a little bit in your founder role. So it's been quite a jump from being an engineer into founder. And most of audience, we all kind of coming from engineering background, and people always look for a purpose. They want to also become a founder. They're looking for ideas to either join or found themselves. But a lot of time, it's a lot different what we imagine. How different it is to be a founder than be just an engineer and work every day on what you love.
It's of course great to be founder, especially once I have such an amazing partner who covers up all the complicated and non-technical part for me. I guess I couldn't do like anything without help of Andre. So yeah, for me it was kind of smooth transition actually from being an engineer to founder, because it was a continuation of my project, which I was working on for a year on my own, and then we suddenly discovered that this pet project was useful not only for our internal purposes, but many other companies and many other developers also could use it for them as well.
And many people believe that if you're building your team from first ideation into first team people that would basically become your partner in crimes, they need to be always smarter than you. Like there is like this paradigm of thinking that if you start like building a team, the first players needs to be like really A players. But how challenging is that? Because if you work on something for a year, you have a lot more knowledge in that regards than anyone else. So theoretically, building the first layer of employees would be almost impossible. So how to break that? How to attract people that are like-minded and could still be good sparring partners?
Yeah, even if you do have a deep knowledge of your own product, it doesn't necessarily mean that you have a deep knowledge of the particular technology your product is using. In my case, I guess the best example would be a distributed deployment feature, which I couldn't build on my own, and that's where we actually hired a person who had a deep knowledge in all this distributed deployment, consensus, algorithms, and so on, who basically carried it on his own, and I was just watching him work and admiring his his decisions, because I really couldn't do something like this on my own.
What is distributed deployment?
Right. So the databases usually work, and especially search engines usually work with huge amounts of data, and those data doesn't necessarily fit in a single machine. So what happens if you want to surf and search through this huge amount, and your application needed, and you basically don't have other option but create multiple machines and distribute the data across them, but still have a single interface to access. It's yeah, but
But
very basic definition.
but is that like also maybe stupid question? But when we talk about distributed databases, are we talking about still single data center, or it's like world-based distribution where you have data located in all kind of machines across the world in different data centers?
Actually, both should work. At the beginning, of course, you want to have machines close to each other, because this extra latency creates problems sometimes. So I guess we started with that, but at some point you need to build a database which is also closer to users in different regions, so they could query their data faster. And this is like step-by-step process. You start with like local deployment within single data center, then you once the project evolves, you want to allow like total distribution as well.
This question will come a lot from front-end engineers, because for us making application faster means basically using technologies like CDN or Cloudflare Worker, where you bring your application really close to the user. So the actual time from ping until the packet is going to be really short. And I'm thinking of the same thing with searches. And I loved part of your presentation as well, where you say, look, we're gonna with every search we're gonna break down every character into a token and cache it locally, or like close to the user application. And I'm thinking, do I understand this properly, that in the future we would also have, similar to CDNs, ability to store vectors or searches closer to the user application? So if I'm searching in Australia, or I don't have to ping back to the German server and basically break it down on specific queries, but it's going to be already pre-cached where the users are.
Yeah, exactly this. We call it like geographically distributed deployment. It's a bit more complicated than just distributed deployment, but it's a goal to build something which can work like this. Yes.
If you look at 2024, and by the way, I always do my New Year's resolutions, and we are at the Christmas time. This is why we're recording this with some Christmas tree behind. Although you don't see Christmas trees, I believe we all have it somewhere. What would be the big vision, technology vision, for not only for Qdrant but overall for industry, for AI, for machine learning? What would be your hopes and predictions for next year?
Right. Well, I guess this year, ChatGPT success was not predicted by anybody. It was a surprise for the community, for engineers all over the world. So we are still processing and still reflecting like what could be done with this technology. And I don't think even like 10% of our possible applications are discovered. for now. So in 2024 we will continue this, discovering more and more for both ChatGPT and vectors as well. I think maybe that huge hype around large language models will be a bit less, will decrease a bit, but still it will be the main topic of the year.
You mentioned several times discovery, and if we break two meanings, so there is a invention and discovery. So a lot of time we inventing technology, and then with this invention we start discovering set of application with large language models. So the large language models was probably an invention, and then ChatGPT itself could be a discovery because there was like a practical set of ways to use that to deliver users desirable outcome. Do you believe that we are also on breakthrough on some inventions that would give a leap forward for new discoveries?
It's
I'm very
hard to predict.
It's a very hard question, but
yeah.
let me just maybe be more specific. Do you believe that diffusion technology is around the corner that would make us independent from energy resources?
No, I don't think it's gonna happen in 20. Unless, of course, large language models could help us solve it. But all process will accelerate this for sure, because we already see that this ChatGPT and other similar types of models are helping a lot with our regular tasks. So I became a huge fan of GitHub Copilot. It basically now writes at least 50% code for me. So I think that should make me at least two times more productive than before. And the same progress and the same acceleration we should see in other topics as well, including the research of nuclear fusion.
Yeah, I would actually bet and hope for practical application for medicine. I myself work for a medical startup, and I could see how inefficient we are and how we still rely on human diagnosis. And I see and believe that anything we do with machines is already could be done a lot better. Mingle, do you believe that vector search and overall machine learning, artificial intelligence will bring medicine to the level that we could cure some stuff like cancer or long-term disease that haven't been uncured for a long time? Like we see evolvement. There was an AlphaFold, but at the same time I haven't seen anything changed in the day-to-day medicine in our life.
Yeah, I think I don't have enough expertise to answer these questions. I have no idea how to how to cure cancer, but I can see that sometimes optimization in like everyday life medicine can be improved with a medical professional, and you should never trust its advices. I think still people will go into ChatGPT and ask their symptoms there. And my personal opinion is much better than googling your symptoms. Because if you find for something specific, you will find something specific. If you query that, like if your headache is a symptom for cancer, you will find confirmation for this in regular search in Google anyway. It might not be as easy to do in ChatGPT.
The three tools that you use on every day and it helps you a lot. And one you've already mentioned, Copilot.
Right. Well, I guess I don't have much like AI tools in my arsenal. I do use Notion for all the project management, but everything else for me is just Markdown files. I make presentation in Markdown. Does it count?
Well, that's incredible. That makes you a true engineer. And I'm very curious, Andrey, what drives your day? How do you get motivation and power to wake up and do what you do? Are there
I
any
see. Yeah.
tips and trips, or I don't know, tricks that you apart from coffee and I don't know what else you drink, but like, what drives you?
Well, I see people wrong on internet. So I guess that's the best. Like if I see that something is done inefficiently, if I see that people are struggle with something and I can help, I can build a better tools to fix this. That's what I would do.
Do you work on weekends?
Yeah, a lot.
And yeah, and just to wrap it up, like you've built an incredible company with Andrey, with your co-founder, and well, again, I met you here. Do you believe that building a distributed team with not single location, but basically team being located anywhere in the world is making sense? Because like when I listen to Sam Altman, he's saying that it's better to have like a smaller team located in one place, and that it would foster their ideation quicker and get them challenge themselves in the same spot. But what you advocating is actually quite a different model. I think both of you
Yeah.
working in Berlin, but most of the team is like everywhere else.
Yes. Yes. So I guess we're speaking a bit about different levels of budget between OpenAI and us. Of course, if I could bring my team in one place and make everybody happy with it, I would do this. But in real life, you have to make compromises, and I guess the location is the cheapest compromise you can.
Great, and I promise to leave a few minutes for announcement about hiring, because I know that you are expanding and hiring and scouting for the best talents out there. What could you share about that?
Right. So I guess we will start hiring actively next year, including the core team, by the way. So I guess it's the best part of the process, because the hiring in open source companies and hiring in uh, other like private commercial corporations is a very big difference. For example, me personally, I just hate the interview process, how it's done in FAANG companies like Amazon, Microsoft, and so on, where you have like 6, 7 iterations of interviews, and you don't even know in which team you're going to be assigned. Yeah, in our case, it doesn't happen. We prefer again practical over theoretical. So we have our open source project. We have all the issues, bugs described there, and I guess it's the best for both the employee and an employer to understand what kind of tasks, what kind of performance we expect from them. So the best thing you can do is you can just go and contribute into Qdrant, and we even pay you for this, even if we don't hire you. Sometimes even if we don't merge your pull request, we still pay. So that's I guess quite fair, and at the same time gives both parties the understanding of what is expected and what the real work is gonna look like.
Great. So then I'm also going to place all the links that we discuss in our podcast description. And guys, if you would like to learn more about Andrey and the Qdrant, please have a look at the description. And I pretty much enjoyed talking, and it's only like probably 1% of what we could mingle about vector, because it's an incredibly interesting topic, and I just wish we would have some follow-up next year.
Sure.
Thank you very much, Andrey.
Thank you for inviting.
And enjoy your upcoming Christmas and New Year.
Thank you, you too.
Ciao, ciao.